Previously, we graphed quadratic functions, and we observed that all of their graphs have the same shape, namely a parabola. This suggests a family of functions, that is, a base function composed with linear stuff. And in fact, we're going to claim here that all quadratic functions are actually quadratic power functions. That is, if we have any quadratic function, right? So if we have f of x is ax squared plus bx plus c, we can rewrite it in a form that shows it as a power function to the second power composed with linear stuff. We can write it in the form a number times x minus a number all squared plus another number. This is called the vertex form for reasons that are going to become clear shortly. Now, the way we're going to prove that we can do this is by developing a set of steps that will let us actually do this. And that process is going to be called completing the square. But before we do that for quadratics, we want to take a moment and note that this is special about degree 2. Right? If we have a higher degree than 2, that's not necessarily the case. So just as an example, let's take a look at some examples of degree 4 polynomials. These 3 degree 4 polynomials all have graphs that have very, very different shapes. So this one is just kind of a flattish U shape. This one has one big dip and then kind of a place where it levels off. This one has 2 big dips and kind of comes up in the middle. And so no amount of like just stretching or shrinking or moving around is going to transform one of these into the other. These have very different shapes. These functions do not form a family. Degree 4 polynomials, we cannot transform one to the other just by composing it with linear stuff. We need to do more if we want to transform one degree 4 polynomial into another. Which is why there's a bunch of neat stuff that we can do with quadratics that we're not going to be able to do with higher degree polynomials.